Okay, so take this second order differential equation, y double prime plus 8y is equal to cosine of t. So the way we're going to do the method of undetermined coefficients is going to be a little different. It's going to be roughly the same. So our test function, big Y of t, is not going to be just g of t. It's going to be a cosine of t, which is our expected term, plus b sine of t. And you may ask, well, why? Why do we need this extra b sine of t? Well, let's say I gave another equation like y double prime plus 8y equals to sine of t. Well, if you just have a equals sine of t, or sorry, your test function was just a sine of t, you're going to be left with a cosine of t, which is the derivative y prime, plus 8a sine of t equals to sine of t. And, well, you have a equaling to 0 because there's no cosine term on the right side. But at the same time, you have 8a equaling 1, which is on the right side. So a would equal 1/8 and 0 at the same time. Well, that would just be impossible. So that's why we need to include the second term of b sine of t. So let's do this. So let's say we can just plug that in. So y prime is equal to negative a sine of t plus b cosine of t. And y double prime is equal to negative a cosine of t minus b sine of t, because you're just doing differentiation of trig functions. So now if we plug these into the differential equation, we get negative a cosine of t minus b sine of t plus 8 a cosine of t plus b sine t equals to 1 cosine t. So now we have a system of equations, kind of, rather than that weird non-existent thing with a no solution. So we can say that negative a cosine of t goes together with 8a cosine of t. And we can say negative b sine of t and 8b sine of t go together equals 1 cosine t. Well, let's see. So this is equal to negative 7a cosine of t. That's 7b sine of t. All that is equal to just cosine of t. So, since there is no sine of t here, b can just simply equal 0, because 7b equals 0 means b equals 0. But since there is a cosine on the right and there's a cosine on the left, you can set negative 7a equal to the coefficient of the one on the right, which is just 1. So a is equal to negative 1/7. Therefore, our solution by plugging in our coefficients for the test functions is negative 1/7 cosine of t plus 0 sine of t. So that just goes out. So we're just left with negative 1/7 cosine of t. Let's quickly get to a t cosine t plus t sine of t example before we move on to our next concept. So let's say we have the differential equation y double prime plus 4y equals to sine of 2t. Well, let's solve for the characteristic equation first to make sure that this doesn't match up with our characteristic solutions. So y equals negative oh no, y equals plus or minus 2I. So alpha equals 0, beta equals 2. So that would mean they come in the solution of y equals e to the 0t plus sine of 2t plus e to the 0t cosine of 2t. So yes, this does match up. So that means, unfortunately, we have to use the t. So say y equals t times a cosine of 2t plus b sine of 2t. So we can just plug that in. So y prime equals a cosine 2t plus b sine 2t plus t negative a sine 2t. Oh, don't forget the 2. Negative 2a sine 2t plus 2b cosine 2t. You take that derivative, you get negative a sine of 2t. Oh wait, I'm forgetting my 2's. Forgetting how to take the chain rule for some reason. 2b cosine 2t plus negative 2a sine of 2t plus 2b cosine 2t. And then find that derivative, so that's plus t negative 4a cosine 2t minus 4b of sine of 2t. Well, that's one mouthful. So solving for that, we get negative 4a sine of 2t plus 4b cosine 2t plus t negative 4a cosine 2t minus 4b sine of 2t. So let's just add this and 4 times that up. Alright, we have this y double prime term to add to this 4y term. So let's go. So we have, let's add up the t trig function first. So y double prime plus 4y t negative 4a cosine 2t minus 4b sine 2t plus 4a cosine of 2t plus 4b sine 2t. And then now we add the non-t terms, so negative 4a sine of 2t plus 4b cosine 2t plus 4. Oh wait, no, that's it. Okay, so when you add these up, these cancel out because negative plus positive is just 0. So all we have left is negative 4a sine of 2t plus 4b cosine 2t equal to 1 sine of 2t. So there is no cosine 2t term on the right side, so 4b equals 0. So cosine term is irrelevant. But there is a sine of 2t term on the right side, and there is negative 4a on the left side. So negative 4a is set to 1. Therefore, a is equal to negative 1/4. Therefore, our solution is equal to y of t equals to negative 1/4 of sine 2t. Okay, so I was going to go on and cover a few more topics, but I didn't want to overload you with a bunch of unnecessary algebra that's really, really complex. So I'm just going to end the video here. Thanks for watching. Yeah, that's it.